Hello, everybody, and welcome to another episode of React Roundup. I'm your host today, Dave Sedia, and on the panel we have Lucas Rios.
Hello, everybody.
And Thomas Alot.
Hello.
And we're joined by our guest today, Dinesh Pandiyan, where we're going to be talking about DevTools and progressive SSR and pretty cool stuff. Yeah, Dinesh, welcome to the show.
Hey, thanks for having me here. I'm super excited to being on the show.
Absolutely. Great to have you.
This episode is sponsored by Kendo React. Progress's Kendo React is a commercial library of UI and data visualization components for React, designed and built from the ground up for React. In other words, it has zero external dependencies. The library includes more than 60 professionally developed, and trust me, they're great-looking components, including powerful data grid with many advanced features such as export to PDF and Excel, plus a vast array of useful components from buttons to drop-downs, a date picker, tree view. They just look great, and it makes your website look great. And they have 3 really polished themes. It augments any existing UI component library as well, so you can use it with other component libraries if you're doing that. You can get a 30-day free trial, which enables you to use the library's complete functionality and access Kendo React's technical support. Now, these guys are legendary. They have a 93% customer satisfaction, and you can get full access for the period of the trial. And your tickets are typically answered by the Kendo React developers themselves. Now, all you have to do to get this trial is to go to kendoreact.com/React Roundup. That's kendoreact.com/React Roundup, and React Roundup is all one word, no dashes or underscores. So go check it out right now.
So could you tell us a bit about your background and like how you got into development and all that kind of stuff?
So I'm originally from India. I started my career as a backend engineer. I was hacking at search engines for a few years. Then I moved to Frontend. Fortunately, when I moved to Frontend, I didn't have to support legacy browsers like IE. I directly started.
Nice.
I directly started with Flexbox and all the latest tools. I never had to worry about things that a lot of people worried in the past. So I feel fortunate. I've heard that before. Yeah. So in the past 2 years, I've been hacking a lot around Frontend. I moved out of India and moved to Kuala Lumpur. I worked in a startup there for a year. And recently, I moved to Sydney. I'm with ThinkMill right now.
So
Nice.
like Sidney, Australia, Sidney?
Yep, Sydney, Australia.
Cool.
And what was the name of the company you're with? ThinkMill?
Oh, yeah. So the company name is ThinkMill. We are a team of JavaScript developers. We heavily work with open source projects, and we are an agency kind. We help other companies build products. And we also focus a lot on open source. We have a couple of open source projects that's been used by millions of users already.
It's really good.
So how'd you get involved in React?
Yeah, so 2 years back, the first project, I was kind of pushed into React project. When I started, the code was, I started with Redux. I started with Redux before I started with React.
Cool.
So it's the first day I opened up the code and we had hundreds of files with hundreds of components and hundreds of state flowing in from different directions. Wow, for 2 or 3 days, I didn't want to touch the code at all.
Yeah, that's a rough welcome.
It took a while, but yeah, I got used to it.
That's really interesting because I definitely worked on a couple of projects that were much more a Redux project than a React project. React was only a detail because it was only like functional components. There was no like set state. So it could have been handlebars. Right, and everything was handled in Redux, and I think there was probably like 1 year span that all the projects that were born on that year span were like similar, which was when Redux was released and got popular.
Yeah,
so
that was kind of the dream, right? Like put all your logic in Redux and your UI doesn't.
Yeah, and then it was like the big decisions, like is it Thunk, is it Saga? Is it observables? Yeah, those were fun times.
I think that was the case. So we had a strict React-only rule. We were not allowed to use set state at all. Anything that don't put it in Redux, use only functional components. It was fun.
Definitely that era.
Yeah.
Yeah, set state considered harmful. I remember the blog posts.
I'm trying not to rant against Redux too much, but good grief.
Was React your first experience in front end, or did you do some front end stuff before that?
I have done some front end stuff. I built websites with HTML. I tried to change some CSS and remember feeling bad about it when things didn't work. And I tried to learn event listeners in JavaScript and figured things didn't work in different browsers before I explored jQuery. Yeah, but that nothing was mainstream. It was all, part-time. I just wanted to explore things in the evening, and I closed the project in the morning. But then full-time, I started working on front-end only 2 years back.
Nice. So how was the transition from like back-end to front-end? Because I feel like that must be kind of a different world. Were you doing like, what languages were you working with and stuff originally?
Yeah, I think it's a totally different world. I was working mostly on the Java tier in the backend. I was working on search engines for top apparel brands. It was fun, when you're writing code that runs on the server is very different. Coming to the front end, you're writing code that runs on a browser, and the browser is going to be very different for each user.
Oh, yeah. And then you throw mobile in there and weird network issues. And
yeah, so the way things got really tricky is sometimes you try to optimize for slow devices, and that slows down things for fast networks. And sometimes optimize for fast networks, it slows down things for slow devices.
So when do you want to be miserable, now or later?
Yeah, that was always better than later.
This is really, really funny because when you try to define front-end programming in like back-end terms, any back-end developer would say like, that's impossible. Like you say like, okay, so you're going to write your code. You don't know where it's going to run. There's no Docker. It's like it may run on one environment, may run on another. So your code needs to be resilient to different environments. You don't know how fast the machine is. It's like a long living process with like multiple inputs of events, and you need to react to these events. People are like, are you crazy?
Mm-hmm. You could lose network access in the middle of a transaction.
Any moment. So it's crazy. Like if you describe front-end programming like in back-end terms, it just sounds like an impossible thing to do.
That's very true. I think the trickiest part is debugging some things in production. If something happens in production for the backend, it's right with you. You can go and debug it directly. I remember directly logging into the production servers and updating JSP files. But when something you have to debug in front end, you don't have the front end. It's executing on the client's machine. Unless you have good logging systems, you won't even know what's going wrong.
Yeah.
Yep. Yeah, I've seen that in reality is like, sometimes there's just a gap in understanding. There are these errors that are happening in reality for some important subset of users, and there's just no visibility into it. Just like money went away. We don't know what happens.
Yeah. Even if you put Sentry and other monitoring tools, you start looking at the errors, and the errors are just like completely crazy. You're like,
that's not possible.
People are running my application inside an iframe, and that's generating an error. It's crazy. It's like you think about everything that is happening. Your code is really like in the wild.
Yeah. Remind me to tell you stories of the NetFront browser someday.
Ooh.
Now is not that day.
Yeah, that's fine.
So debugging this stuff, like when it's running on client browsers, is difficult. But when you're in development mode, you've got handy tools in the browser, right? Like we have console logs, we have like browser dev tools. It's really handy. And like React has its own dev tools. So can you talk a little bit about like React dev tools? I know you've worked with those a bit and written some blog posts and such.
I think React dev tools is pretty awesome. Given all tools are great, but hands-on coming, all of us can agree. Console log will be the greatest debugging tool of all time.
Yep.
No matter how damn fancy.
Greatest of all time.
No matter how fancy the toolset gets, we always go back to simpler things. All right. Given said that, all the latest frameworks, it is more about scaling complexity. If you take a simple to-do app, we don't even need frameworks to connect. We have built it right. But over time, when you add more complexity, that is when these frameworks shine a lot. You don't have to slow down your development. You don't have to bust your head a lot to figure out what's going on. Frameworks, the code scales easily with frameworks. Same case with dev tools. Once, if dev tools help you navigate the unfamiliar territory in code. In other words, if you don't have no idea what a code does, dev tools tells you exactly what it does during runtime. And that's why it's pretty great. It saves a lot of time for everyone when we use the dev tools right.
Yeah.
Yeah, I feel like the dev tools debugger, like I don't use it all that often, but when I need it, I definitely need it, right? Like that's usually like the second phase after console log.
I find a lot of people have very little insight in how to use the dev tools, even just the browser dev tools, but especially not like the React dev tools themselves, especially with the new version 4 that just came out. What do you think are like the most surprising features that people don't know about?
I think the DevTools shines really good in you can benchmark your performance, and where it really wins is you can find weak links in your project. By weak links, I mean there are a lot of things, pitfalls that can slow down your application, right? So usually there are expensive things that slow down your application and cheap things that doesn't necessarily slow down your application. If you just play around with DevTools, and within 2 minutes, you will know where the weak links are in application, and you would be able to spot it directly right on point and be able to fix it.
Yeah, to be honest with you, I think that being good at the DevTools is almost like a superpower. I think this is one of the super like differentiators in productivity. And the new DevTools for React, like the fact that you can track who created what, like in terms of the component, right? So this kind of thing, like the fact that the DevTools knows about the React tree in itself, and then you can track context and you can track those things. It's really powerful when you are working with these super gigantic applications with lots of shared components from your company, right? You have like a bunch of shared components that you did not create at all, and then your application is just like, I don't know, slow. And you're like, oh my God, all right.
Yeah, that's huge.
That's very true. That's why even I felt when I first started using DevTools, it gives you superpowers. That's what I would say. Say, for example, I recently got involved in a project. That project is really huge. And the original team, original developer that owned the majority of the project developer is not there anymore. All right. I went in, I wanted to explore the project, and I had no clue how the code was flowing in. You have hundreds of files, you have thousands of lines of code. Real power while building applications is the mental model, right? If you just have two components, you can easily figure out how the code is flowing. But on an application level, you have to build a mental model of how the data flows from top down, where things change interactively.
And then not forget it.
yeah, that's right. If you use DevTools, it can help you build that mental model pretty easily.
Yeah, of the new features, I think the one that is one of the most interesting is that rendered by.
Yeah, that's huge. I only just learned about that today, actually, from your blog post.
Yeah, this is really interesting because you want to know, like, you kind of find the component that you're trying to debug, and you want to know where in the code it is being instantiated. So only by looking at the resulting DOM and the resulting React tree is not enough. So the render by is one of those tools that can help you with a lot of searching.
Yeah, that's very true. So take these both examples, rendered by and why this render. React is all lifecycle, right? A component can render and things can happen based on a lot of scenarios. For example, props can change, states can change, hooks can change. And a parent component renders a child component to render. The new DevTools in the version 4, they have this new feature called, it is titled as why did this render? When a component renders in the profile, you can exactly see which prop changed and triggered a render, or which state changed and triggered.
That is so huge.
This one feature alone saved me hours of development time. Previously in version 3 of DevTools, I used to use 20 different console logs to figure out which changed where.
Yeah, that's super useful. I remember there was like a couple of years ago, I found some package called Why Did You Render? And it was like kind of useful, but it was also way too noisy. Like it just told you, it just flooded your console with things that changed. And
back in the day, I built some crazy stupid tools using I used Node.js. I ported over the Chrome DevTools over to run headlessly in Node.js and speak to the browser over WebSockets. Now that's called, what is it called? Puppeteer. So you can just use Puppeteer now. But we didn't have Puppeteer back in the day, so I did all this. And then you can use that to script the actual rendering engine. So I would use that to dynamically add console log breakpoints to every line of the code that I cared about automatedly. It slowed everything down, but it gave you this incredibly detailed flow of exactly what line of code fired before which other line of code, which was so huge, but it was just so much effort to dig through. I think this is the first time I've ever mentioned this tool. you'd have to dig through all these crazy logs, but you could finally do it. It was like the first time in history you could actually get this data. Now it's just like, it was just use React DevTools v4 and you're done. You're good. Man, where was that?
That's pretty crazy, given especially debugging in JavaScript, when you have promises without DevTools, it's almost impossible to debug.
Yes. Oh, good grief. And then, I like, don't get me started.
Yeah, async stuff is the worst, right? It's like, oh, what called this thing? Like, oh, well, nothing directly. It was queued up a while ago.
And then like cross-frame communication, and then there's like stuff happening on the server and on the client that's like all part of it. Oh, good grief. Encapsulation and function-oriented programming saves so much headache.
Yeah, I think that this is a really strong selling point for React and for any of these like established frameworks or libraries or whatever. The tooling that starts building around it, that's when it starts paying off. That doesn't make sense. Like when you start having those things, like it doesn't matter if you just found a framework that is better. It's just like, I'm not a big fan of Webpack, right? But you cannot deny that there's a bunch of tooling now to inspect your bundle size. When those tools to inspect your bundle size like started appearing, that was like crazy. It's like, oh my God, why do I have 2 low dashes in my, this kind of thing? It was
only 2. You're doing great.
You. Those things were invisible to you. So this is the interesting part. And we talked a lot about the XState library with David and other people interested in state machines. That's the same thing. Like it gives you tooling so you can visualize things. This is when some tools start like paying off, is that when you have these toolings, and I can live with a lot of pain points of React because of the DevTools.
That is very true. As a coding example, I work with both React and React on an everyday basis. And React DevTools version 4, it doesn't work with React now.
Ooh.
So having worked with React DevTools for a while, now if I have to choose between React and React for any project, given no trade-offs are there, I would choose React just for the DevTools.
Oh, wow. Didn't think about that.
Yeah. So how do the DevTools for React compare to like the DevTools for like Java? Because you did a bunch of Java stuff back in the day. And I know like the tooling story around Java is just insane, how much great tooling there is.
Yeah, when I worked with Java, I pretty much stuck with the IDEs and breakpoints. I think it was pretty straightforward. If you compare between front-end tooling and back-end tooling, I think it all comes down to debugger. If you have a decent debugger that can stop where you want it to stop, you have majority of things. And all the other things showing currently what are the variables available for you in the breakpoint, within the closure, outside the closure, those things are good to have.
Yeah, I guess the other issue with backend is like if you've got multiple interconnected systems, and so maybe your code is fine, but like the database is slow, and now you've got to go figure out how to like profile your SQL queries or whatever.
No thanks.
Yeah, not super fun.
It's complicated.
Yeah.
In the backend world, I've been doing a little bit of backend programming lately in a Java service. We are using a Datadog here. So every service that we deploy, we have a Datadog agent in the server. So an interesting thing is happening is that I can trace individual requests, and then you can see what's happening. Just like a React profile tree that you can see like which components are rendering which components, I can see like which services are being accessed for one given request. So you say like, cool. I'm spending a long time here on my Java microservice, but then I'm most like waiting for, I don't know what. You have all the tracing. You can go into tracing to the different services, and Datadog creates like a graph of all your services. You can see like how they're connected. Cool. It's pretty amazing. Like it's real-time monitoring of your production system. So yeah, there are interesting things happening too. The fact that everything is in our servers makes it kind of,
Makes it easier, yeah.
Yeah, but to be honest, the most difficult parts of the backend programming I'm seeing lately is much more like the infrastructure parts than actual code part. Like accessing databases, transforming requests, making response. That part is like easy. That part is not the problem at all. The problem is like, how do I put this in the Kubernetes? I don't know what, and it's like became like a crazy configuration, like juggling game. That probably like the most complicated part of doing backend.
Yeah, it feels like backend's getting really complicated, and it seems like even so, if you've got tools like Datadog and you can analyze the performance in your own backend, you've still got to send that stuff over the network to the client. So, like if that's sort of like this middle zone that you don't really control, and so if you're on a slow network, or if your users are on a slow network, then your app can end up being slow, even if your backend is fast.
Yeah.
So we've got stuff like server-side rendering, and Dinesh, you talked a bit about progressive server-side rendering, and can you talk a little bit about like what is SSR versus PSSR, I guess, and how those work?
Yeah, sure. It's a super interesting topic. So it's not a very common practice because there are a lot of challenges around it. But if you explore into it, we can gain a lot of performance gains around if we use progressive rendering right. To put it in short terms, right now in the recent framework world, in the front end, we have these two popular concepts, client-side rendering and server-side rendering, right? Essentially, client-side rendering means you render and all the stuff, it happens on the browser on the user's client. Server-side rendering is all your rendering, generating the HTML happens on the server. So you essentially generate the HTML on the server and send it to the client. Now, the progressive rendering is part of the server-side rendering, but essentially, HTTP is originally designed to be a streaming protocol. All right, what that means is if you watch a video, you don't have to wait for an entire 10-minute video to download in YouTube. You can just start buffering and streaming 10 seconds of videos. All right, you can start playing before the video comes in. So this works based on the concept of streaming. So the same way we can do for rendering server-side stuff. Since HTTP is streaming protocol, HTML can be streamed from the server. So essentially, if you have 200 kilobytes of HTML in the server, it doesn't have to be transferred to the client in one request. We don't have to wait one request to be transferred altogether. We can chunk it into 10 kilobytes and send them as 20 different responses in small chunks. So this comes into play especially if you have a huge page, you have 5 different containers in the page. And if you want to render things on the server, rendering doesn't necessarily mean just HTML. You have to wait for the data to come from the services. So of the 5 containers, let's say first container takes less than a second and other 2 containers takes a while to get the data. You don't have to wait on the server for your entire content to be rendered and sent to the client. So once the header is rendered on the server, you can stream it to the client. And once the next important portion of this render again in the server, you can stream it to the client. So essentially, progressive rendering is without having to wait for the whole HTML to render. Even if portion of HTML is rendered, you can chunk it to the client. And browsers are more than capable of rendering the chunk without waiting for the entire HTML to come in.
Yeah, because browsers were engineered from the beginning to work on dial-up connection. So everything had to be streaming because that was the basis of how everything would have to work in order for anything to work. And it's fascinating, like Facebook, even, before React and all this stuff, has been doing that kind of, chunked flushing to the client for forever. And I think they had a concept called Big Pipe, where they would first send in like the frame of the UI as one chunk, and then progressively, stream in each different chunk of content that had all of the JavaScript and all of the HTML. They were still doing server-side rendering at the time, but with just like jQuery-esque, not literally jQuery, but scripting on top of that. And now moving that over to a React world, they've kind of had to go back and reinvent all that stuff. There was recently a talk they gave at the last D8 conference, or I forget what it's called. F8, that's it, where they talked about the new architecture for Facebook.com, where they're doing that, like actually sending JavaScript inside of the GraphQL response data, that the JavaScript that is required to like render the content that's sent. There's all kinds of really advanced techniques that you can get.
Yeah.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open source Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
If we talk about like chunks, setting chunks does not get like the whole picture, right? This big pipe thing, it's a technique that it's not that you're sending parts of your page as you render them in the server. It's more like you're sending one HTML, like let's say the loader, and the loader is rendered. You are doing whatever you want in the server and generate more HTML, and then you send to the client like a small script that say, okay, now you hide that loader and now you render what I'm sending you right now. So it's essentially like you are completing your page chunk by chunk. You're actually also replacing parts of your page according to what's happening in the server. Yeah.
Yeah, it kind of blurs into the kind of recent concept of micro front ends, where you have, like on the server side, microservices or separate services that talk to each other over a streamlined API. But getting that to work on the front end with UI, like how do you make that work? There's a bagwillion different techniques about it. I'm sure there's going to be yet another one coming out any minute now that's going to replace everything and be awesome. It's an old problem, but very few people seem to be focused on it. And I'd love to hear, like, what have you discovered and, like, what are you seeing and what advice do you have us? Because you're kind of living in the future there.
I think all the problems we solved for the web 10 years ago, we are right now in the time where we are resolving all the problems for JavaScript.
Sounds about right.
Yeah. So
that's kind of the nature of the beast.
So essentially, if you take any site that doesn't do server rendering, right? So in today's world, we use the frameworks. Take React, for example. Even if you have 500 KB of initial load, in slow networks, it might take at least 5 seconds for the 500 KB to load on the client. So your client's browser is a sitting duck. There is just a white screen without showing anything.
That's horrifying.
Yeah. So when you server render previously without JavaScript, server rendering is essentially you can generate. It's just HTMLs are generated from templates. You don't have to wait for the whole HTML to generate and you can start chunking. But now in the JavaScript world, since everything is run by framework, your framework has to do one complete pass of the HTML from top to bottom. That means you cannot generate and send things back to the client before the whole HTML is generated, whole tree is generated. Recently, to beat this downside, what we've been doing is we've been doing a bit of mix of both server-side rendering and client-side rendering. What that means is take an average page. You have a header and you have a body that has critical content and you have non-critical content on the side. So how people approach this problem is they render the header and critical content on the server, send it to the client, and in the client, they again make a API request, fetch and AJAX calls and load the non-critical content. But again, we go back to the same problem. When you depend on the client to render things, you have to wait for the API request. You have to wait for the JavaScript load to complete. So this progressive server-side rendering, I think it bridges the gap between client-side rendering and server-side rendering. It uses the best of both worlds. In client-side rendering, you don't have to wait for the whole page there. You can just make AJAX requests asynchronously. In server-side rendering, you can quickly render and send things to the client. So in progressive server-side rendering, you can quickly render, and without having to wait, you can chunk things to the client. So essentially, you're slicing things on the server, and you're sending it to the client.
Mm. like that's an awesome concept, but like how do we make it real and how do we use it? Are there any like specific things that we can take off the shelf and just like plug in and start to use? Or
so I've been experimenting around this concept with Express servers. So in Express, you have this API called Readable. So readables are built for streaming things. You can stream anything from an Express server. So if you're generating HTML, you can create a readable API and generate a header and send it to the client. So in any REST endpoint, you put your stuff in each portion of your page into an Express readable, and you use send to send it back to the client. And Express takes care of streaming it. You don't have to do anything else. You just use the API.
Yeah, because I remember if you're like doing that from PHP, you have to do it like a specifically call like flush to the browser. But I think Express, yeah, you're right. Express just handles all that, the flushing and all that stuff for you.
Yep.
It seems like where you draw those lines in the HTML becomes really important then, right?
That is one of the challenges of progressive rendering. So essentially, HTML is hierarchical, right? Let's take an example. In a body, let's say you have 10 divs. Let's name the div 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. With progressive rendering, you have to send the chunks as 1, 2. It has to be in sequence.
Right.
If, for example, based on your requirement, if div 3 is more important than div 1, you cannot send div 3 ahead of div 1. You have to send 1, 2, 3, and 4 later. But
unless
CSS Grid solves this problem for us.
Yeah, nice. Right. So you can sort of like assign a place where it's going to appear and you can render things out of order.
Yeah.
Exactly. Without CSS Grid, it would have been impossible. So since we use CSS Grid, you have placeholders and you have portions reserved for the element to be there. So once you stream, your browser takes care of putting it in the right spot.
Another awesome thing that you can do with this is you can stream script tags. So you can actually, I just remembered this is a technique I toyed around with a really wacky side project I'll talk about later. You can create JavaScript for the client on the server side, stick it in a script tag, and then stream that as a chunk. So if you wanted to, send div 10 first and then send div 1 later and actually set that, you could just have a script tag that says, okay, just move div 1 above div 10 and, the user is none the wiser.
But this CSS grid is really interesting. So you define what they call grid template areas. Is that what it is? So if you define grid template areas, when you start streaming, it doesn't matter where the div is inside the grid. It will always be in the area that was assigned, right?
That's right.
That's amazing. CSS Grid is a game changer.
It truly is.
Can we use that yet? Like, what browsers don't support that?
So CSS Grid has two levels of specifications, right? Grid specification 1 and 2. So 1 is supported in all the browsers that are currently supported. It works even in IE11. So CSS Grid specification 2 doesn't work in IE11 though.
Yeah, it was a very successful release. They did a pretty good job in. The interesting thing is that I think it started in IE, right? But then
I think yes.
Then they got stuck in the first version. So that's one of those interesting ones.
Yeah, because I remember playing around with Grid for IE only years and years and years ago. It's like, this is the best thing in the world, but we can't use it anywhere, so forget it.
It's really interesting. The fact that you can really define your layout without needing to change your HTML is because you still need to do that with Flexbox.
Yeah.
That's a game changer. Enable things like that. Yeah.
And you can even dynamically redefine the positioning and order of elements depending on the media query. So if you have somebody that has a constrained browser or if they're looking at it in portrait, you can totally just rearrange the layout with no JavaScript, which is so huge.
Yeah, I love when that happens.
No offense to JavaScript.
So about the progressive rendering part, I had one issue when I was working with SEO-related pages that needed to be really fast. So we ended up working with streaming the HTML. So we got even more fast. We we already had maybe a 2-second page load on average on our measuring thing, and it became like 1.5. So it was like a 25% increase. That was really good. But there was an issue that as soon as you start streaming something, your HTTP status code becomes 200. So we lost a little bit of monitoring abilities there, because we would send a bunch of HTML and then we start fetching the entity that we were about to render. And if there's a 404, if there's a 404, we would send an error, a page to an error chunk to be rendered. Like, unfortunately, we didn't find, but your page is still 200. So we lost a little bit of monitoring. You can't change status code after you start streaming. And we started streaming because of the SEO benefits, but Google penalizes you if you show an error page without an error status code. Yeah, so it was like that performance boost, is it being good or bad for us? Because we had a bunch of 404s with 200 status code happening.
Yeah, that's tricky.
So there is a concept called, I think it's transport headers, is that it seems that you can stream HTTP headers too. And then you can change. Yeah, I think they're called transport. And then, correct if I'm wrong, people who are listening to this. Yes. You can't send like headers while you're streaming that will change the contents of your previous headers, but not all clients understand it, and you can't change all the headers. And HTTP status code was one that the Google bot was not able to understand the change. So
I think it introduces additional challenges there. So you render the critical content, it's all good. Then when you try to render non-critical content, if you get a 500 or 404, there is no way we can fix that right away.
Yeah. So it's been a while I don't work with server-side render. I think I'm a little bit less stressed in my life now. Like those are the type of errors that was like, this is the kind of thing that is so specific to the thing that you're doing, and there's not much like documentation anywhere because it's very specific to. And
you just got to figure it out. It seems like that and the HTML slicing thing are both kind of maybe general cases of the halting problem. Like you need to kind of tell the future, like what's this going to look like when it stops running before I do anything. And
that's
doesn't work so well if you're trying to make it fast.
So speaking about progressive rendering, I've not looked at it, but a lot of people are like sending me links every time I talk about it. It seems that in the Phoenix framework of the language Elixir, they have something called Live View Now, that it opens a WebSocket with the server, and you don't need client-side frameworks to generate dynamic contents. It's like every user interaction, you send a small request to your browser, the browser server-side render what needs, and then it gets like rendered where it should in your page. Does it make sense?
Yeah, it's really cool.
Yeah, I did not play with that, but it seems like maybe it's the next step to something like that, because it's streaming, but a two-way streaming, right? You could also send a message from the client to the server in the middle of the streaming.
It doesn't scale well to like Facebook scale. Like I really wanted to push for something like that quite a few years ago, but they told me, do you have any idea what that would do to the data center? Like billions of open WebSocket connections? No.
Yeah, that seems like that's the trick there, is like you sort of make a trade-off of like open like memory and stuff on your server. You're shifting more to the server.
You have to have at least one process per user using your website.
Yeah, it depends on what you're doing, maybe.
But Elixir does really well with that. Elixir can do. I think they had some demo a few years ago of like 2 million concurrent connections on one server or something. So
that's huge. That's
Elixir is built to do lots of, because they're like really lightweight threads.
Yeah, it's the Erlang thing. I think WhatsApp for a while.
Yeah, WhatsApp uses it.
Yeah, it's
Erlang, right?
They had like 1 million users before they had their second server. Wow. It's something great. I think
Erlang's for like also next level.
Yeah, they are. Elixir, Elixir is built like with it generates like Erlang VM code, so it's the same like runtime as Erlang, so that's why they can do these fancy things. But even with normal server-side rendering, it's always a trade-off of, am I going to do the computation, or is the client's computer or phone going to do the computation? So sometimes you're in a scale, even you're too small or too large, that your service cannot cope with everything. So that's where like React client-side rendering is good for you, because it's not, you don't need to pay for those computation cycles, right?
Yeah.
That's an interesting trade-off.
Yeah, I guess the trade-off is that it becomes potentially less accessible to people with slow connections and slower hardware and that kind of thing. Or maybe they just don't like how slow your website is and they leave.
Yes. Maybe the solution to dynamic performance is not putting stuff dynamic in your pages. Try to do as much static things as you can, because
back to 1995. Just like
let's do it.
HTML.
Time is Roman.
Yeah, if you look at it, a handful of years back, we assumed our mobile devices were not really powerful. We thought, hey, a few years down the line, we won't have this problem. Everyone will be having powerful devices. But what happened? We started building even more powerful websites, and the problem is still the same. I think we have this tendency to keep pushing that boundaries to make things difficult. It's both good and bad in the same way.
Yeah, I think that's like the forever state of computers. It's like software keeps getting slower as the computers get faster. And
this is crazy. I don't know where I read the other day. It's like you buy like the latest gamer laptop. You know, those laptops that have like different colors, and they're like they run like the craziest. And you open a web page and it's dropping frames. It's like you're running the craziest games and everything's smooth, but you open somewhat pages that are not even that complex and the animation is dropping frames.
I feel like performance is going to becoming a thing maybe that people seem to spend more time on. I mean, with games, those things are optimized to within an inch of their life. Like they're trying to do all this fancy graphic stuff. And websites, I think, for a lot of years, we've just been focused on like getting stuff on the page. And maybe we've got to spend some more time trying to optimize things now.
Yeah, I think, over time recently, in the past few years, as a community as a whole, we have solved this problem of making things easier to build things. With these frameworks and stuff, things are not difficult to build anymore. Now you can see more and more money and investment and energy is being spent on optimizing for performance. Yeah. I think if we give it a few years, we would solve this performance problems as well. But we definitely have one other problem to solve. Something else is going to come up.
Yeah, there's always that thing.
I remember when I was complaining to somebody at Facebook about like React Native, some of the ways that it was architected back in the day. It's like this is not going to scale well to scale down to some of the devices of the day. And he said, by the time this is actually shipping, hardware will have gotten so much better that it's not an issue anymore. And just like that was such an epiphany for me. It was like literally, I mean, we had the data to know like devices of this class that people buy them here, they stop using them here. We knew that however many months or years down the road of development cycle of like hardware is going to shift. We knew, like, we talked to the people from Qualcomm. We knew their roadmap. We knew everything. Like, it was absolutely certain we can use this architecture technique because it'll be fine by the time it matters. That was pretty crazy.
It's really interesting, like next level planning there.
Yeah. Don't underestimate Jordan.
Awesome.
It's good.
We've been recording Ruby Rogue since 2011, and we've talked to a lot of people who have had a really deep influence, not only on the programming community, but also on the Ruby community. And as we've talked to these people, it's become apparent to me that we talk a lot about the things that make them interesting that they've done, but we don't really get into how they got into programming or how they came up in their career, how they got to be the person who invented whatever library or technique that they came on the show to talk about. And so I put together a show where we actually highlight these things. We talk to them about how they got into programming. We talk to them about how they got into Ruby. maybe how they got into Rails. We get a little bit deep into what makes them tick and why they are the way they are. And then we talk about what they're working on. We talk about the things that make them well known or make them interesting. And a lot of times it's the stuff that goes beyond the code that really makes these people tick and makes them the kind of people that we want to hear about. And so I put together a show called My Ruby Story. You can find it at myrubystory.com. And it's where I interview these people and just get the stories of these people and how they came into programming. So if you want to hear inspirational stories or get ideas on how you can actually advance your career, then go check it out at myrubystory.com.
We should move on to picks maybe. Lucas, do you have any picks this week?
All right. So I have 2 picks this week. First is a blog post of a coworker. I really like his blog in general. His name is Ben Hoyt, and he has been learning Elm on the side. It's interesting because he has a wedding registry website that people actually use with actual users, and he uses this website as his like learning environment. So he was learning Go and he ported like the backend to Go, and he wanted to learn Elm and he ported the front end to Elm. So it's really interesting the way that he has a real world application that he did. So there's a lot of knowledge when he writes about these things, because he's not creating a prototype or anything. It's something with real users, with a real use case. So this is really interesting. So Ben Hoyt's post on learning Elm. And my second pick is not programming related. I bought a cast iron skillet.
Interesting.
And
just to go with the knife you got recently.
Exactly. So I have like every 2 months I buy something. So now it's the cast iron, and it's really good. It's like I never cared about like cast iron pans or anything like that. It's really amazing. You can make great steak, great everything. You can put in the oven, the whole thing. You can even bring to your grill, vegetables, everything. So good. Highly recommend having one. And Lodge, which is the most famous one, they're cheap. It's not like a $200 thing that you buy. It's very accessible.
I guess it's just a big chunk of metal, right?
You have no idea how much people can charge for big chunks of metal.
Yeah.
True. I guess my computer's just a bunch of silicon, right?
Yeah, right.
If you're buying like Le Creuset,
right.
Iron,
those cast iron pans are not cheap.
Yeah. Fine. You got me.
So these are my 2 picks for today.
Cool. How about Thomas?
Yeah, so I've got one pick for the day. It's not directly programming related. So I've got kids, and I've been reading this issue of the 2019 Awake magazine. It's in 211 languages and 64 million issues. But this one's particularly 6 lessons children need to learn. And just thinking about these, teaching my kids and making sure I'm doing good there, but really thinking about these lessons and applying it to my life of like, the benefits of self-control, how to be humble, how to be resilient. It has so much applicability as an engineer of just like, if I can both training myself and kind of mentoring new engineers that are coming up, just focusing on like, these are the core lessons you need like as a human being in any walk of life. And how am I doing as far as like resilience? How do I handle, when things inevitably go bad, and how can I improve there? I've always been on a self-growth kick, and this was just a particularly good one.
Awesome. Thanks, Thomas. Dinesh, you got any picks?
Oh, yeah. I usually explore a lot of productivity apps, and I'm this crazy person that wants to put everything that I want to do in a day in a to-do list. I easily can strike off 10 to 50 items every day, and I use this amazing app called Todoist. I think it helps me stay on top of my task, and it's pretty amazing if you're this person who wants to make sure you don't miss anything, don't forget anything. Todoist is pretty great for that. I've been using Apple Notes for a while, but recently last month I switched to Bear Notes, and the user experience is amazing. It helps you navigate through your stuff pretty easily. Those are my 2 picks.
Oh, Bear is nice. Yeah, I like Bear.
Yeah, it's cool. Great.
So I've just got one this week, kind of related to our talking about Live View. I saw an article, I think last week, called On the Utility of Phoenix Live View, and a guy built pretty much like a live markdown editor. with live view. So as you're typing, you've seen those like side-by-side things where you have text on the left and markdown on the right, or whatever, markdown on the left and rendered on the right. So as you're like typing text and it's like live updating the markdown on the server and sending it back down. And it's pretty impressive. So you can check that out. And I'll put in the link to the Hacker News comments too, because there were some interesting discussions there. And I think that about wraps up this episode of React Roundup. Thanks for being here, everyone.
Goodbye.
We'll talk to you all next week. Bye.
Thank you. Thanks for having me.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.